Hello students, today I am going to discuss a topic that is to find out number of solutions in some modulus equation in the form mod x minus a plus mod x minus b equal to c graphically, where a, b, c all are real constant. Now if we consider that if we plot the critical points a and b here on the real number line, and the corresponding distance between a and b if we consider as equal to d. Now there are three cases which may arise to find out number of solution graphically. So first case is that when the given constant term on the right hand side of this modulus equation, that is c, when it is less than the distance d, then what will be the case? When c is greater than d, then what will happen? How many number of solutions will be there? And when c is equal to d, then how many number of solutions will be there? That we will discuss. Okay. Now from the basic algebraic definition of mod x, if we consider, then we can consider separate region for x, and based on the concept of mod x equal to x for x greater than equal to 0 and equal to minus x for x less than 0. So based on that concept, we can find out the number of solutions, but that will take a lot of time. So to save our time, to find out the number of solutions graphically, we can apply the distance concept of the modulus. Okay, so as we know that in case of modulus, if we think of that mod of x minus a plus mod of x minus b is equal to c. So here this first term mod x minus a represent the distance between a and variable x. So here a is constant, and similarly for mod x minus b, this will be the distance between variable x and the real constant term b. So basically this modulus equation represents the sum of the distance is equal to c. Now we have considered here three cases. Okay, so as I have considered here three examples just for our understanding purpose. Okay, so the first example you can see here that mod x plus 3 plus mod x minus 5 equal to 4. So if we think about this particular critical points here, so if you plot on the real number line, so what are the critical points? Obviously minus 3 and 5. Okay, so let us understand each of these cases separately to find out number of solutions graphically. So case number 1, to understand that, we have chosen that mod of x plus 3 plus mod of x minus 5, that is equal to 4. Okay, so as I mentioned, what is the critical points here? This is mod of x minus of minus 3 we can represent plus mod of x minus 5 equal to 4. So according to that, the critical points are minus 3 and 5. So minus 3 and 5, they are the critical points. Okay, so now our next step will be to locate these critical points on the real number line. Okay, so if we draw this number line, and based on that minus 3 and 5 we have located here. So as you can see, there are total 3 regions have been formed by these two critical points. Okay, so if we name these as region 1, region 2 and region 3, so there are total 3 possible regions in which x may lie. Okay, so if we consider first of all that the location of x is in region 1. Okay, arbitrarily I am choosing one position for x. So let us consider this is x, right? So what about the first term here, that is mod of x plus 3, which means the distance between the variable x and the constant term minus 3. So according to that, this much distance we can represent as mod of x minus of minus 3, which means mod of x plus 3, right? And What about mod of x minus 5? Obviously this will be this much distance. Okay, now we have to understand first what is the distance between the critical points here. Okay, so what is the distance between minus 3 and 5 on the real number line? Obviously distance will be 8 units. Whereas in this first case we can see that the sum of the distance is equal to given as 4, whereas we can already see here that mod of x minus 5 has already exceeded this 8. Okay, so obviously from that this equation to satisfy mod of x plus 3 has to be negative so as to satisfy the first case, so which is not possible because any modulus expression is non-negative. Okay, it is always greater than or equal to 0, so it is not possible that x can lie in this region. Fine. Similarly, if we consider the location of x in the third region, let us consider this is x, so according to that this much distance will be mod of x minus 5, and following the similar analogy, this much distance will be equal to mod of x plus 3. Once again we can see here that this mod of x plus 3 has already exceeded the distance between minus 3 and 5, so which is obviously not possible here since mod x minus 5 has to be negative in that case to satisfy the given equation. But as we know that modulus expression is always non-negative. Okay, so according to that we can conclude here that x cannot lie in region 1 as well as region 3. Now coming to region 2, if we consider that x is located somewhere here in between minus 3 and 5, so according to that this much distance will be mod of x plus 3 and this much distance will be mod of x minus 5. So here if you add them, how much we get? We get equal to 8, but here in our question the sum of the distance given as 4. So we can see that either of these three regions the value of x is not going to satisfy the given equation. So according to that we can say in case number 1 there is no real solution exist. No real solution of x exists for the first case. Okay, so now we can tell that if we apply graphical method then we can find the number of roots very easily and very quickly. Now coming back to the second case where the sum of the distance equal to 8. Okay, the sum of the distance mod of x plus 3 plus mod of x minus 5, that is equal to 8. So to understand this, if we refer to this diagram we can see here that the sum of the distance equal to 8 is possible if and only if x is lying in between minus 3 and 5, because the distance between these critical points minus 3 and 5 is already 8, so x has to lie in between minus 3 and 5. So from that we can tell that x has to lie in between minus 3 and 5. So according to that how many real solutions will exist? There will be infinite number of real solution of x. So we can infer now that mod of x minus a plus mod of x minus b equal to c, and if d is the distance between a and b, then for c equal to d number of solution will be infinite. Whereas for c less than d number of solution will be 0. That is for the first case. Now if we look at the third case where the sum of the distance equal to 10, the sum of the distance equal to 10, so that means C is greater than D here. Okay, C is greater than D here. So how many real solutions for X will exist, that let us understand. So again, to understand it, how many real solution of X will exist, similar procedure we will follow. That is, we will locate the critical points -3 and 5 on the real number line, and already we have seen earlier that the distance between them is equal to 8. So here we can see that the sum of these two distance is equal to 10, which is obviously greater than 8. So according to that, we can tell that X can lie in this region either, or X can lie here. Okay, because the sum of the distance has already exceeded 8. Okay, so based on our previous explanation in case of case number 1 and case number 2, so we can tell here that X can lie anywhere in region 1 or region 2. That means if X is less than -3, then that region is also possible for X, because we can see here that this much distance is for mod of X plus 3 and this much distance is mod of X minus 5, which is obviously the sum of these two is greater than 8. So obviously which may be equal to 10. And similarly, if we think about this region of X, that means region number 2, here also this much distance is mod X minus 5 and this much distance is mod of X plus 3. So it is also possible that their sum of the distance will be equal to 10. So if X is less than -3 or X greater than 5, these two regions are possible for X here to satisfy the third case. So according to that, we can tell that for some specific value of X which is less than -3 and for another specific value of X for greater than 5, this equation will satisfy, because this is obviously equation, not inequation. So that is why we will get some specific value of X, not some interval. Okay, so obviously it is evident here that we will get total how many solutions? Total 2 solutions we will get. Okay, so when the distance is less than the given constant on the right hand side of the modulus equation, we can tell here that number of solution of X will be equal to 2. Okay, so I think all these 3 cases are clear to everyone, that how to find out graphically the number of real solution of modulus equation in this particular form, where the sum of the 2 modulus is given as some specific real constant. Now how to find out those solutions, for that you can refer to our next video. So I hope you have enjoyed this. Thank you for watching.